So I'm going to share my screen. Bless you. I'm going to come over here to our little equations review and start my slideshow. Start from beginning. All right, y'all ready? All you need to do is watch and listen and make sure you know what's going on. So equations of lines. We have horizontal, which goes side to side, like the horizon. Like, do you remember from last year in Algebra 1 or whatever year you took algebra? You all passed Algebra 1, okay? Horizontal is this way. Did your teacher teach you HOI bucks? That's the acronym I always use. Or if you heard the HOI bucks. Okay, brand new to you then. It's not a word. Neither is PEMDAS, okay? It's just an acronym to help you remember it. Horizontal, HOI, has a zero slope. That's what the O is. So does that make sense that this is zero? It doesn't go up or down, right? Horizontal, zero slope, and the equation is y equals something. Y equals 7, y equals -4, y equals 100 million. HOI. Horizontal, 0, y something. Got it? HOI, right? And then bucks. Vertical is this way. It has an undefined slope, right? Straight up and down. And the equation is x equals something. X equals 4, x equals -12, x equals 9 billion. Okay? HOI bucks is your little acronym. So when you look at this one, is that horizontal or is it vertical? What? Horizontal. That's HOI. HOI. So the equation will be y equals something. And what number do you think it's going to be? If you had to give it a guess. Y equals 2 is the equation. Good job. All I need you to do is listen and pay attention. We're going to practice a couple more. All right. Is that horizontal or vertical? Horizontal. That's HOI. So it's going to be y equals, what number do you think? Y equals -3. Perfect. All right. That one is vertical. That's bucks. It's going to be x equals something 1. X equals, you can't see the 1 because the line went through it, but x equals 1. Good. See, you guys are good at this. All right. All you have to do is listen to your teacher and you're going to understand it. It's really not all that hard. All right. Vertical, bucks. It's going to be x equals -4. Beautiful. All right. Now, this is not a horizontal or vertical. For this one, it is y equals x. Do you guys remember y equals mx plus b? Remember, like, months of your life in Algebra 1 was y equals mx plus b? M is the slope. What do you notice is the slope of this line? Like, it goes up how much over how much? 1. Do you see how it's 1? So it's y equals 1x, and it goes through the origin, which is 0. So it's y equals 1x plus nothing, but we just say y equals x. So when you get that diagonal line through the origin, it's y equals x. And if it goes downwards instead of upwards, what do you think it will be? Instead of y equals x, it'll be y equals, you guys are so smart, -x. That's it, okay? Let's just try a couple more. Is that one horizontal or vertical? I heard both that time. It's vertical. That's vux. So it should be x equals 2. Good. How about that one? Horizontal. So y equals -1. Beautiful. What's that one? Y equals -x because it's going downwards. And then this one is y equals +x. Okay. Thank you for paying attention. That's it. Now we have reviewed lines and we're ready to start our notes. All right. There we go. So let me come back over here, stop sharing, and we're ready to actually write some stuff down. So what we're going to do is symmetry. You just need to understand lines in order to be able to do symmetry. But in your own words, because you've been alive for 16 years, you know what the word symmetric means. What do you think symmetry means in your own words? You really can't be wrong. I just want you to say it. When you hear that something has symmetry, what does that mean? Same on, yeah, on both sides. Or like you could fold it in half, basically. Okay, so same on both sides. Same on both sides. So something that has symmetry. Again, it's going to be common sense. Most of geometry is. Been alive for as many years as you have, you know what symmetric means. Same on both sides. So there's two types. There's line symmetry and point symmetry. So line symmetry is a line cuts it in half. So you can draw a line through your shape that will cut it in half. Or in other words, if you were to fold on that line, it would be the same on both sides. So like if you folded it in half. If you don't want to write it down, fine, but can you guys at least look up here? You're gonna have you have to know this, all right? And it's not all that difficult. All right, a line cuts it in half. So you could draw a line or you could fold it, and it would be the same on both sides. Or actually, you know what? Let me. I got this at our professional development yesterday, so I'm going to use my little fidget guide. Could I draw a line on this guy and cut him exactly in half and have it be the same on both sides? Yeah. Do you see how if I cut him right here, same on both sides? That's line symmetry. Okay. Point symmetry means it's going to look the same upside down. What it really means is if you rotate 180 degrees, it will be the same. So if you rotate 180 degrees, but in other words, it's the same upside down is going to be point symmetry. So let me show you with my little guide. If I rotate him 180 degrees, is he the same right side up as he is upside down? Does he look the same? No. So he does not have point symmetry. You have to be able to rotate it 180 degrees and have it look the same upside down. Okay. So here, we're going to practice it. Point symmetry, line symmetry, or both. So looking at this one, could I draw a line through it that will fold it exactly in half? Yeah, same. Okay. So for this one, yes. Line symmetry. Now, it could be both, though, so hold on. And you just need to look up here. You don't have to turn your paper unless you really want to. If I take that and rotate it 180 degrees, does it look the exact same? No. Do you see how the top of it is flat now, but this way the top of it had like this point on it? All right, so it is line symmetry, but not point symmetry. It's not the same upside down. If I rotate it 180, it's not the same. All right. How about the sunshine? Could I draw a line through it that cuts it exactly in half? Yeah, in fact, there's a lot of them. I could cut it here. This is another line of symmetry, because sometimes you get asked, like, how many lines of symmetry are there? Do you see how there's a bunch? How many lines of symmetry are there? What is that, 4 lines of symmetry? I didn't draw them very well, but anyway, yes, line symmetry. And then point symmetry. If I take it and flip it upside down, is it the same? Yeah. All right. If you rotate it 180 degrees, it's the same. So we get both for that one. What do you think about this one? Does it have line symmetry? Yes. If I draw a line through, I can fold it exactly in half. And then how about point symmetry? If I flip it upside down? Yeah. So it's both. All right. How about the letter S here? If I draw a line through, is it the exact same on both sides? Like if I folded it, does it match up? No. Okay. And how about, so not line symmetry, all right? How about if I rotate it 180 degrees and turn it upside down, is it the same? Yes. Okay. So that one would just be point symmetry. All right. You can't fold it in half and have it match up exactly. All right. Good job. That went well. This is another one of those things where I don't have a better explanation than, hey, look, right? Geometry is shapes and stuff, right? So lines of symmetry go through the center of the shape. They're going to go right through the middle. That should logically make sense. And we're going to write down what I just reviewed on the little PowerPoint, all right? Horizontal lines have a 0 slope. They're flat. And they go through the y-axis. So that is hoi. Horizontal, 0 slope, it's y equals a number. Y equals 7, y equals -4. Can we close the computer because I'm trying to teach you? Vertical was vux. So what did the U stand for? What kind of slope did the vertical lines have? You learned it in Algebra 1. I'm just reviewing it. What was the U? What kind of slope? Undefined. Good job. Undefined slope. And they go through x-axis. So it's vux. Those are going to be x equals whatever. X equals whatever the number is. The number is the easy part because you just look at the graph and go, oh, there it is. This is going well. You guys are listening to me and we're all good. So hoi vux. But you have to understand the lines in order to do lines of symmetry. Okay, so go ahead and flip over. We're going to draw some shapes that have specific lines of symmetry. So looking at this one, what is this line? Let's see if you can give me the equation. First of all, it's horizontal, so hoi. It would be y equals 2. Good job. That's your line, y equals 2. And can you draw a shape that has symmetry around y equals 2? Just if you folded it on that line, it would have symmetry. I'm going to draw something like this. You can be creative and draw something different if you want. But do you see how that line cuts it exactly in half? Yeah, again, if you want to be more creative than I was, mine was sort of basic. But again, that y equals 2 just has to cut it exactly in half is all that we're doing. All right, what is the equation for this one? It's vertical. Good, x equals -3. Perfect. X equals -3. And again, I'm going to draw something. You can copy mine exactly, or you can make up your own thing. But that line has to cut it exactly in half. I'm not super creative when it comes to the pictures. So if you're more of an artist and you want to draw something that's a little bit more intricate, you totally can do that. But as long as that line cuts it in half, then you're good. All right, here's our y equals x. So I need that line to cut my shape exactly in half. Let me see if I can draw something that'll work here. Something like this. I'm going to do a triangle. Again, if you are more creative than me, feel free to draw something more intricate. But do you see how it cuts it? Do you see it? If you fold along that line, it's cutting it exactly in half. And then you can do the same thing with y equals -x. I'm going to just draw a square for that one. Let's see if I can make this work. Yeah, that'll work. So again, it goes right through the center, cuts it exactly in half. My pictures weren't super creative, but that's okay. Oh, no, your shape does not have to hit the origin. This one happened to. I drew a square that just kind of, the origin was at the center. There's a lot of different things you can draw. I'm not super creative with it. If you were like an artist, you could draw something really intricate over here and then mirror image it on the other side. I'm not even going to try and do that. Okay. The other, so that was symmetry. Are we okay with symmetry? Fold it in half. Not super complicated. The other thing we're going to look at is translations. But screen and put this on the recording too. Let me share. I'm going to go over to Delta Math. What you can do, and some of you did this already as I was walking around. I saw you did this. You can open your, I'm going to let you open your computer while I'm talking. I know I'm going to trust you. Okay. If you go over to Delta Math, I put a little activity in there so that you can practice some translations. But maybe here, watch. I'll show you one of them, and then you guys can play around with it. We'll play with this for a minute. Translating simply means you're moving something. So if you want to watch, I'll do one, and then you guys can practice. Now you have to know your right from your left. Okay. It says translate the figure 4 units right and 3 units down. All I'm going to do is take all of these points and make them go 4 to the right and 3 down. So look, I'm going to take this point. I'm going to go 4 right, 1, 2, 3, 4, and then 3 down. 1, 2, 3. And I'm just going to do that with all the other points. I'm going to take this one, go 4 to the right, and then down 3. And then this one, 4 to the right, 1, 2, 3, 4, 1, 2, 3. This is super fun, right? And then this one, we're going to go 1, 2, 3, 4, 1, 2, 3, and then one more. 1, 2, 3, 4, 1, 2, 3. There. Does it look like the exact same shape, but I just scooched it a little? See what I'm saying? Okay. So I'm going to go down here, hit submit. It's going to give me a green check. All right. I'm going to go back and show you one of the, oh, it even moves it. Look at that. That's cool. It looks three-dimensional now. Oh, that's neat. I love delta math. All right, so I'm going to go back and do one of the other ones, and then you guys can play around with it a little bit. This one is going to actually, I think, put like a plus and a minus in it. Is that what this one does? Oh, no, this one is asking you how it moved. You have to be really careful with this. Again, don't fade out. I'm going to give you a minute to practice this, okay? So that it's not me talking at you. You have to go from the correct one to the correct one. It says we want to go from V onto W. If you do it the other way around, it's going to be backwards. We want to go from V to W. So, hey, guys, look it. If I go from here to here, did it go up or down? It went down, so I'm going to choose down. Oh, sorry, it's doing left and right there. We'll do down first. It looks like it went down. Let's see, 1, 2, 3, 4, 5, 6. It looks like it went down 6. I'm just counting. And then left or right? Yeah, to the left, how much? To the left. All right, to the left, how much did it go? 1, 2, 3, 4, 5, 6. 1, 2. It looks like 4 to me. But you can just hit try and it'll move it. Let's see. Left and then down. Whee, it matches up. Okay, so I'm going to pause my recording. I want you to all just take a couple minutes. I'll put like a 5-minute timer up and just try a few. It's not for a grade. It's just for you to practice messing around with it. And then we'll do our notes on it. For note sheet, we're going to write down our notes for our translations. So the pre-image is the place where you start. The image is the place where you end. And you have to be really careful about which one's which, because otherwise you're going to do it backwards. Okay, so hopefully you just saw in the delta math, it's really important to understand which one you start with and which one you end with. It's not difficult, but again, if you do it wrong, you're going to get it backwards. Now, for example, this is the notation we use. If your pre-image is the points A, B, C, your image is going to be A prime, B prime, C prime. We call those little tick marks prime. It just looks like an apostrophe. And the point is so that you can tell the difference between which one is which. So your start is just going to be the letters. Your end is going to have those prime marks in them, just to make them look different. Okay. So a translation simply means that you're moving up, down, left, or right. Kind of like a slope, really. I'm going to go like up 3 and right 7, or whatever it is. Now this is called isometric. And sometimes you do get asked, like, is this transformation isometric? All that means is, it's just a fancy word that means the size is the same. The size didn't change. You just picked the shape up and put it somewhere else, but you didn't make it bigger or smaller. So it didn't like stretch or shrink. So the size is the same. So isometric just means the size didn't change. That is all. That's a fancy word that just means it's the same size. You just moved it somewhere else is all. So we're just going to try 2 of these, and then I will stop talking at you. You have some time to practice. So we are going to move right and up. When you move right and up, that means you are adding. Does that make sense? If you go to the right, you're going to add. If you go up, you're going to add. Okay? So we want to take this point, -2, 1, and we're going to go 3 units to the right and 4. Actually, let's go ahead and plot that point first. -2, 1 would be right here. And we want to go 3 units to the right and 4 units up. So I want to take my -2 and I want to add 3 to it. 3 units to the right. And then 4 units up, I'm going to take my 1 and I'm going to add 4 to it. So I'm adding because it's to the right and it's up. So what would the new point be if you just work out that math? -2 plus 3 would just be 1, and then 1 plus 4 would be 5. And if you plot that, 1, 5 would be right here, And then you can just count the little boxes and check. Like basically, if you can count, you can do this. Does it look like it went 3 right and 4 up? Yeah, you just check. It went 3 to the right, 4 up. Again, kind of like a slope, sort of. Now, if you move down or left, you're going to subtract, okay? So if we want to take this point, we want to move it 2 units to the left. So I'm going to take my -2 and I'm going to subtract 2. Again, going to the left, you have to subtract. Going to the right, you're going to add. Left is subtract. And then 1 unit down. Can anyone tell me what you think we're going to write here? If I want to take my y value, yep, 1 minus 1. So then you just have to do the math for that. -2 minus 2 be -4, and 1 minus 1 is 0. And then you just want to check. We started at -2, 1, and we ended at -4, 0. So does it look like we did what we said we were going to do? Like, did it go 2 units left and then 1 unit down? Like we went left and down. And if you want to use your notation, this would be A and this one would be A prime. So it's like this is where you started and this is where you ended. That's how you can tell the difference between them, the starting and the ending point. I'm going to say one more thing. I'm going to say it so it ends up on the recording. This part down here is what? This work. Am I going to take this paper from you? No. Where are you going to enter your answers? On Schoology, and you get 3 attempts. So please use them. I'm giving you plenty of time. I know some of you have been kind of tired. That's fine. Just wake up long enough to do this so I can enter. I want to enter 100. It's the first grade going in for the new quarter. If you do it and I enter 100, Power School will calculate your entire second quarter as a 100%. It'll be a nice little, emotional boost for all of us. Okay.